Alright, hey guys, thank you for clicking on that link. This is talking about copper tube and fittings, Module 7. I know where most of us should be familiar with copper tube and fittings. We've dealt with it in my intro class. The objectives here, upon completion of this module, you'll be able to do the following. Identify the various types of copper tubes, identify material properties, storage, and handling of that tube, identify types of fittings and valves, identify techniques used in hanging and supporting copper tube, properly measure, cut, and join copper tube, and identify the hazards and safety precautions associated with copper tubing. Performance task: select correct types of materials for copper tube systems, identify types of fittings and valves and their usage, select the appropriate PPE for working with copper tube, and correctly measure, cut, join copper tube. Select the correct support and spacing for the application. So hey, let's get right to the lesson. Copper is a mineral that is mined from the ground. Pure copper can be melted and molded into various sizes, lengths, and angles. Copper was first used in plumbing in the early 1800s. Wow. And has widely been used in hot and cold water systems since the 1930s. Alright, our first note deals with annealed copper. Annealed copper is produced by an annealing process in which the material is heated and cooled slowly cooled. Write that down. The next note talks about copper tube sizing. Types K, L, and M and DWV use nominal or standard sizing. This means the outside diameter is always 1/8 inch larger than that nominal size. So if you have a 3/4 inch nominal type K, L, or M in DWV, if it's 3/4 inch nominal, it will be 7/8 inch OD. So just note that. ACR, I'm sorry it's not a note right here, it's not highlighted. Just note that ACR uses actual OD sizing, okay? Moving on down here, another note, couple of them. We're talking about color codes of the various types of copper. M is color-coded red, and ACR is color-coded blue. This is the labeling down the sides of the pipe. Alright, we're talking about joining pipe. Dissimilar types of metals can cause a process called electrolysis. Well, how we join them to prevent electrolysis is dielectric unions. So if you attach unlike metals such as copper and galvanized pipe, you should use a dielectric union right there. Write that down. I just want you to know you're doing really wonderful. Alright, keep up the good work. Next, we're talking about alternative fittings. If more than one T is to be installed in a line, a straight piece of tube with a link between T's should be 10 times the tube's diameter and to reduce turbulence, okay? So if you have a 1-inch T, it should be 10 inches between that first T and the next T, and this helps reduce turbulence. If you have a 4-inch here in the example, it says 4-inch T's should have a minimum distance of 40 inches. So it's literally taking the size of the tube or the T and multiplying that by 10, and that's how close minimum those T's should be to reduce turbulence. Alright, this method right here, we're talking about the T puller. It's a mechanical formed T. Just note that, just write this down. Mechanical form T's increase productivity because you create only one brazed joint. Meaning instead of putting a T here, where you would go braze here, braze here, braze here, or solder, 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 what you could do is use this type tool, pull this section out of this straight run of pipe. It'll look like this. And then you just braze this straight piece of pipe in there. So it's one joint instead of 1, 2, 3. So mechanically formed T's increase productivity because you only use one joint. Next fitting we're talking about is short bite fittings. They are a push fit connection that uses a stainless steel teeth, alright, and a compressible O-ring. I think the note is you should focus on the stainless steel teeth and sharp bite. Alright, we're talking about measuring pipe. There'll be a couple of different questions about this right here. Center to face, use with a length of tube that has fittings on both ends. Alright, just know that. and then the length is equal to the measurement of the center of the fittings to the face of the copper fitting. Alright? It's the measure of from the center of one of the fittings to the face of the opposite fitting, plus twice the insertion length. I think there may be two different questions there on this. Specifically this first part, where I stopped highlighting, and then there. Alright, end to back. The tube length is equal to the measurement plus the length of the sweated on fitting. Sweated on fitting, you know that we're talking about actually soldering. So just note that, end to back, tube length is equal to the measurement plus the length of the sweated on fitting. Alright, next, we're in progress here. So this step says make the cut by rotating the cutter. Alright, so immediately after making that cut, you should use the built-in deburring tool to remove any burrs. And that's talking about using the handheld tube cutter. Alright, next we're talking about increasing productivity or really saving fittings. A good way to save fittings on soft copper is we can actually bend it. Certain kinds of soft copper tube can be bent, and this saves fittings. Okay. The next note down here: copper tube should never be joined using a threaded joint. That's because it's soft, and as you rotate the fittings together, you could damage the soft copper by literally spinning it and breaking it, or even if you don't break it, you would make it significantly weaker and possibly reduce its life. But the most important thing here is a very short question. Copper tube should never be joined using threaded joints. Next, we're talking about the soldering definition. Here it says soldering is a type of heat bonding in which copper tube is joined when a soft filler metal is melted in the joint between the two tubes. Alright, capillary action. So note this: solder melts and flows into the gap in a process known as capillary action. The next note here, when we're talking about flux, one of the steps to soldering, you apply flux. Or flux is a paste that acts as a wetting and cleaning agent and aids the soldering process by preventing oxidation. Now we're going to talk about installing hangers and supports. The tube attachments. Important note here: a tube attachment is the part of the hanger that actually touches or connects directly to the tube. Alright, your clevis hanger, I know we've installed these. This part right here is the part that actually touches the tube, okay? The tube attachment actually touches or connects directly to the tube. Makes sense, don't it? Huh? Next, we're talking about insulating tubes. Alright, one of the insulation materials is glass fibers. I think you should know that. You see what I'm saying? And lastly, we're talking about pressure testing. You can pressure test copper tube with either air or water. And that's it. Well, thank you so much for watching this lesson on Module 7, Copper Tubes and Fittings. I hope you had a good time.